All right, so let's solve this logarithmic equation, and it is in the form of a quadratic logarithmic equation, but fear not, it's just a pattern we have to recognize and then solve. So the first thing is that recognize that this is log x squared minus log x squared equal to 24. It's actually, when you change the form, the first term, log of x squared, you can leave that alone, but the second term, that is 2 log of x, according to one of the log laws, and set that equal to 24. Okay, so now I'm going to bring everything to one side. So log of x all squared minus 2 times log of x minus 24, set that equal to 0. Now this is analogous to saying y squared minus 2y minus 24 equals to 0. All I have done, I just changed log of x to y. That's all I did. And you can notice that this is a trinomial, and it's factorable trinomial. And it's very easy to solve this one. So basically, this will end up being y minus, two numbers you multiply, you get minus 24. And that would be 6 and 4, and one of them has to be negative. The bigger one has to be negative, so that would be negative 6, and then y plus 4. Set that equal to 0. So this is an equation. We're going to use a product rule, so this will end up being y equals to 6 or y equals to negative 4. Okay, this is a zero product rule I'm using. That means each of these brackets must be equal to 0. So if the 6, y minus 6 must be equal to 0, therefore y must be 6. Y plus 4 has to be equal to 0, therefore y has to be minus 4. What was y? Well, y was log of x. So I'm going to rewrite log of x equals to 6 or log of x equals to negative 4. Now simply you change this log form to exponential form. This says 10 to the power of 6 equals to x. That's the first solution. This one says 10 to the negative 4 equals to x. Now, where did I get the 10 from? Well, the base of the log right here, this is 10. We didn't write it, but by default, by convention, if we don't write anything down, the base is 10. So here the two solutions we got, and you can go back and plug it in and then solve, and making sure that it works, and it does work for both of them. Okay, simple as that. Changing the logarithmic form in a sense that we use a quadratic factoring to come up with the possible solutions, and we've done that.